Let's talk about how to calculate the measures of angles formed by tangents and secants in circles. There are three places that two lines could intersect in relation to a circle. Two lines could intersect somewhere inside of the circle, like these two green lines. They could intersect on the circle, like these two red lines, or they could intersect outside of the circle, like these two blue lines. So let's talk about how to calculate each of these angle measures based on where the lines intersect. If the lines intersect inside of the circle at the center, then they're actually just central angles, and we learned how to calculate their measures in a previous video. The measure of a central angle is just equal to the measure of the arc that it intercepts. So the measure of angle BCA would be equal to the measure of arc AB, and the measure of angle DCE would be equal to the measure of arc DE. And since these are vertical angles, you would actually know that the angles are equal and the arcs are equal. But what if the two lines intersect inside of the circle, but not at the center, like this? In that situation, each of the angles is equal to the average of the arc that it intercepts and the arc that the vertical angle intercepts. So for example, if I wanted to calculate the measure of angle AFD, this angle right here, I would find the measure of arc AD and the measure of arc BE, add those two arcs together, and take half of it. And that would be the measure of angle AFD, and of course also the measure of angle BFE because they're vertical angles. Or if you wanted to calculate the measure of angle EFD, you would find the measure of arc ED and the measure of arc AB, add those two arc measurements together, and take half of it, and that would give you the measure of angle EFD and AFB. What if the lines intersect on the circle? Well, that's actually just an inscribed angle, and we learned how to calculate their measures in a previous video as well. The measure of an inscribed angle is equal to half the measure of the intersected arc. But that's true even if one of the sides of the angle is a tangent instead of a secant, like in this diagram. The measure of angle BDE would be equal to half the measure of the intercepted arc, which would be arc BAD. And the measure of angle BDF would be half the measure of its intercepted arc, which is arc BD. So although this angle looks different than a typical inscribed angle that we're used to seeing, it's the exact same idea. Since the vertex of the angle is on the circle, it works the exact same way as an inscribed angle. The measure of this angle would be half the measure of the intersected arc. Okay, well what if the lines intersect outside of the shape, like this? In order to calculate the measure of angle BAD, so this little angle right here, you need to find the measures of both of its intercepted arcs. So this angle intercepts arc BD, and it intersects arc EF on the other side. So you'll subtract those two arc measurements, EF minus BD, and take half of it. Always make sure that you're subtracting the big one minus the little one. You should end up with a positive angle measurement, never a negative one. So this process is true regardless of whether it's two secants that are intersecting, or two tangents that are intersecting, or a secant and a tangent that are intersecting. You find the measures of both of the intercepted arcs, subtract them, and take half. Find the measures of both of the intercepted arcs, and take half of it. And take the measures of both of the intercepted arcs, subtract them, and take half of it. So in a nutshell, what we've learned is that if two lines intersect inside of a circle, then the measures of the angles created are equal to half the sums of the opposite arcs. If the lines intersect on the circle, then the measure of the angle is half the measure of the intercepted arc. And if they intersect outside of the circle, then the angle's measure is equal to half the difference of the arcs. So if they intersect inside, add the arcs together, divide by 2. If they intersect on the circle, just divide by 2. And if they intersect outside of the circle, subtract and divide by 2. So let's take a look at a few examples. Our first one is definitely the easiest one because it's two lines that intersect inside of the circle at the center. These are called central angles because their vertex is the center of the circle, and central angles are equal to the measures of their arcs. So the measure of angle TPS would be 67 degrees because the measure of its intercepted arc is also 67 degrees. Now to figure out the measure of QT, this arc, there's a couple different ways that you could go about it, but either way the math that you're going to end up doing is subtracting 180 and 67. So you could think about this as a semicircle. Semicircles always add up to 180 degrees, so I would do 180 minus 67 and get my answer of 113. But instead of looking at the arcs, you could also look at the angle measurements. This is a linear pair, and since we just figured out that this angle is 67, again you would do 180 minus 67 to figure out the measure of angle QPT, and you would know that the measure of its arc would be equal to the measure of the central angle, so again you get the answer of 113 degrees. Our next example is similar because the lines intersect inside of the circle again, but it's different because this time the lines don't intersect at the center of the circle, instead they intersect at point U. Therefore, we need to add the measure of the intercepted arc of the angle that we're looking for, angle TUS, to the measure of the vertical angle's intercepted arc, which is 79. 79 plus 91 is 190. Take half of that and we get our answer of 85 degrees. So then I'm supposed to find the measure of angle RUS, which is just a linear pair with the 85 degree angle that we just calculated. So I can subtract 180 and 85 and get my answer of 95 degrees for the measure of angle RUS. The next angle is an inscribed angle because its vertex is on the circle, and we already knew from a previous lesson that the measure of an inscribed angle is equal to half the measure of the intercepted arc. So I'll just take 70 and divide it by 2 and get my answer of 35 degrees. And our next problem is really the exact same thing, it just looks different. This is still going to work just like an inscribed angle, even though one of the sides of the angle extends outside of the shape. It's a tangent. If I want to calculate the measure of angle SQU, well, I'll just take half of the intercepted arc. Half of 164 is 82. Then to find the measure of angle SQT, I can just subtract 82 from 180 because these two angles form a linear pair. So the measure of angle SQT must be 98 degrees. The two lines in our next diagram intersect outside of the circle. So to calculate this angle's measurement, angle TQU, we need to subtract the measures of the two intercepted arcs. Always do big minus small. You should get a positive answer when you subtract. And then take half of it. So 107 minus 27 is 80. Take half of that, and I find out that the measure of angle TQU must be 40 degrees. And the next problem is basically the same idea. The lines intersect outside of the shape, so I will subtract their two intercepted arcs, 259 minus 101, and then take half of it, and I get an answer of 79 degrees. And our final example is the same idea. We have an angle formed by two intersecting lines outside of the circle. So I will subtract the two intercepted arcs. So that means that this 194 measurement isn't going to get used in my calculations. I just need the two intercepted arcs. 118 minus 48 is 70. Take half of that, and I find out that the measure of angle TQS is 35 degrees. And that's all you need to know about calculating the measures of angles formed by tangents and secants. In our next lesson, we're going to discuss how to calculate the lengths of segments that intersect inside of a circle.